Hello and a very good evening to all of you. I hope all of you are doing well. So, in today's class, we'll be discussing functions in C. So, to begin with, let us throw a light on main function. So main function is considered to be the entry point of any C++ program. So it marks the beginning of the C++ program. So what does it basically implies that? It implies that main identifier in the function main marks the beginning of function definition in memory. That means main itself is the address of the main function in the computer's memory. So this is the point in time where you need to start the compilation from and the execution from. So whenever you want to execute main function, you need to simply provide the address. So this is the point in time when the execution starts from. So it further implies that main function is the starting address or the pointer to the program in the computer's memory. So this is a very important statement one needs to remember. Okay. So in case it's not only true in case of main function, but it applies to any function. Any function name marks the beginning of function definition in computer's memory. Now, it is the point where the compilation and the execution of program starts from. Now, every C++ program has to have only one main function because you cannot have two starting points. So what you can have is you can have only one main function. Now, just see here the syntax is given, void main and the body of the main. So here, the return type of main is specified as void. Now, in main can return either integer or it can either return void. Now, there might be a question that may be striking your mind that to whom main function returns value. Main function returns value to operating system kernel. Okay, operating system kernel basically means the core program of the operating system. So user will request the operating system kernel, the operating system kernel will call main function, the main function will return value to operating system kernel, and the operating system kernel returns it back to the user. So that is the way how the invocation relationship is established. Now you need to remember that by default the return type of any function will be integer. So if main returns integer, it can return either a zero value, it can either return a non-zero value. Okay, so if it returns a zero value, then operating system kernel learns that the program has normally terminated, and if it returns a non-zero value, that basically implies that the program has abnormally terminated. Now let us talk about C++ function prototype. Now C++ function prototype is basically a mechanism of declaring the function. It's a way of letting the compiler know that what are the characteristics of a particular function. So a function prototype is a declaration of function that tells the program about the type of the value returned by the function and type of the parameter and the number of parameters taken in by the function. So this is the significance of the prototype or function declaration. So function prototype describes the function's interface to the compiler by giving details such as the number and the type of arguments and the type of return value. So it lets the compiler know that what kind of value that function takes in, what kind of value it returns, and how many value it takes in, right? Again, now the function prototype declaration looks just like function definition, except that it does not have any body or the code is missing. That basically means in case of function declaration, the entire syntax will remain same, only the body of the function will be missing, right? Again, and in addition to this, you see that in case function declaration, the names of the arguments, okay, are also optional. So you can specify only the data type and you can skip the name in case of declaration. So for an example, if I want to declare a function that adds two numbers, so we can write here, as in this case, we can write only integer sum, integer. So n1 and n2 in case of function declaration is completely optional. Okay, right? So this is one of the characteristics of function prototype. Okay, so the prototype declaration looks just like function definition, only that only the thing that is missing is the function body, right? So a declaration introduces a name to the program, where a definition tells about what the function is doing and how it is doing. So whenever you declare, it will basically provide a program information about there exists a function by the particular name, and whenever we define the function, the definition says that what the function does and how it does. Okay, So here, this is a typical example of typical syntax for declaring a function. So you have return type, you have the function name, and you have the parameter list. Okay. So an example would be integer sum, integer n1, integer n2 with a semicolon. So here n1 and n2, as I've said, is completely optional. Okay. So here return type basically specifies what is the type of value that function returns. So if return type is not specified, by default, as I've said, it will be integer. Name of the function is an identifier that reflects the name of the function. Okay, right? It marks the beginning of the function definition in memory. An argument list is the type and the number of elements that the function takes in order to perform operation. In case of function prototyping, the names are completely optional. So here, in case of a function prototype, prototype is always followed by a semicolon, right? Again, so it has to end with the help of a semicolon. So these are the important things that you need to remember. Now, function definition. Now, as in case of function declaration, what we need to have is we need to have different sections in case of function definition. So whenever we are defining a function has a function header and a function body, right? Okay, so this is the function header and this is the function body, right? Okay, so the function header specifies the function return type, the function name, and the parameter list, whereas the function body specifies the operation that the function performs. So here the return type specifies the type of value returned by the function. Okay, so it can be any valid C++ data type. If no type is specified, then by default it will return an integer value. The parameter list will provide the list of list of parameters that the function will take in and the type of the parameters that the function will take in. Right. So a function may be without any parameters, in which case the parameter list is empty. So this is implied. Okay, this is implied. So you may have or you may not have a parameter list, right? You may not have return type, but in case if you do not have return type, by default the return type will be integer. So here what we have done is we have taken up an example, right? Okay, of a multifunction program that is capable of adding, subtracting, multiplying, and dividing the numbers, the integer, two integer numbers, right? Okay. So here, just see, these are the prototypes of the function: integer add, integer subtract, integer. Just see here, what we do not have is we don't have the names of the variables specified, because as I've said, the names of the variables are completely optional. So what you can do is you can simply specify the data type that the function takes in. So now here what I've done is I have defined my main function. Okay, right? I've defined my main function. The return type of main is void. I've taken up two variables, that a and b, that are type integer. I've taken in the values of a and b, right? Okay, and then what I've done is I've called individual functions by passing a and b. So whenever I call add, this call will be linked to the definition, because add here, you see, this add here will mark the beginning of function definition memory. So the function definition lies somewhere here. So it will add up the content, it will return the sum of the values. Okay, right? Likewise, I've called subtraction. It will link the function call to the function definition that lies here, and it will return the difference. Then I've called multiply. It will multiply the value of a and b by calling the function multiply, right? Again, and then it will return the product of these two numbers, and divide. Again, it will divide a by b and return the value here, right? Again, so here in case of divide by 0, I've taken up some exceptions as well, so you can go through it. So you need to execute this particular program as well. So just see here, what I'm trying to do is I'm trying to explain you a multifunction C++ program, where what you are doing is we are declaring a set of functions, and then we are defining the functions eventually in order to make the function perform certain operations. Okay, right? So this is one of the program that you need to execute. So all the program that you have that has been tagged has to be executed, right? Now, to see, there are different ways of invoking a function in C++, right? So as in case of C, there are two ways of invoking a function, that is called as call by value and call by reference. Call by value and call by reference. Okay, right? So these are the two ways in which what you can do is you can call a function. One is by passing value and one is by passing reference. So in call by value here, what happens is that So these are the two ways of calling a function, that is call by value and call by reference. So in case of call by value, what happens is, you see, just listen to me carefully. In case of call by value, the value of the actual parameters are copied into the formal parameters of the function. Okay, so here what happens, the original values are unchanged and only the parameter inside the function changes. Now what does it basically imply? So in case of call by value, what do? We do is we copy the value of the variables into another set of variables, right? Again, and in any the former set of variables are called as actual parameters, and the latter set of variables are called as formal parameters, right? So actual parameters are copied into formal parameters. So if any change is brought about to the formal parameters, the changes are not reflected to the actual parameters. So that is what is the intention of call by value. So in case of call by value, the actual parameters are copied into the formal parameters. Any change made to the formal parameters are not reflected to the actual parameter. Now just see here, this is a very simple example of call by value, right? So here what I've done is I've declared a function swap that takes in two integer values. Okay, it takes in two integer values. These are values. Okay, so here what I have is value 1 and value a and value b. So I have read the values. I have read values into variable val a and val b. Okay, right? I've read values into variable val a and val b. Now I'm printing the values of val a and val b. So for example, if value a is 5 and value b is 6, so it will print 5 and 6. So since value a is 5 and value b is 6, so it will print 5 and 6. Now I'm calling the function swap by passing value a and value b. Now just see here, what happens is that this value a and value b, these are called as actual parameters. Okay, value a and value b are called as actual parameters. Now what happens whenever the function will be called, value a will be copied to value x, where value x is another variable, right? And value b will be copied to value y, where value y is another variable. So separate memory allocation will be done for value a and value b, and value x and value y, right? So value x and value y are variables that are just holding the values of value a and value b. So value x will be 5 and value y will be 6. So here I'm printing the values of x and y, value x and value y. So this will print 5 and 6. Then I'm swapping the contents of 5 value x and value y, right? So whenever I'm swapping the contents of value x and value y, it does not bring any change to the values of value a and value b, right? Because value x and value y are simply the copies of value a and value b. So now I'm printing the value of x and y after swap. So this will print 6 and 5, right? So here it will print 5 and 6. Here it will print 6 and 5 because the values of x and y have been swapped. Now once the function execution is over, it will go back to the calling function, that is main. So it will return the control here, right? Okay, and then it will execute this particular statement. It will print the value of a and b. Now value of a and b has not changed. Value of a has remained 5 and value of b has remained 6. What has changed? The values of x and y has changed, where x and y are copies of a and b. So here again it will print 5 and 6. So this is the importance of call by value. So in case of call by value, the actual parameters are copied into the formal parameters. So any change brought about in the formal parameters are not reflected to the original parameters or the actual parameters. So the original parameters will remain unchanged, right? So this is what happens in case of call by value. Now let us consider call by reference. Okay, let us consider call by reference. So in case of call by reference, what happens is that the address of the actual parameter is stored into the formal parameter. Now this is the major difference. So in case of call by reference, what you do is you store the address of the actual parameter into the formal parameter. So if any change is brought about using the formal parameter, so since formal parameters are pointers, so any change brought about using the formal parameter will be reflected to the actual parameter. So this is the major distinction between call by value and call by reference, right? Okay, so here just see, in order to make you understand, I've taken up the same example, but here instead what I've done is I've taken up I've declared swap using that takes into integer pointers, right? Okay, so here just see again, I've read the values of a and b and I printed the values of a and b, so this will print 5 and 6, right? Okay, then I've passed the address of a and address of b, right? So value so address of variable a will be copied to a value pointer variable val x, right? Okay, and address of value b will be copied to pointer variable val y, right? Okay, so here just see what I've done is I've printed the value of x of a and b using the reference to a and b. So val x is reference to a, val y is reference to b, right? So it will print the value that is held by the address location held by val. So valx is pointing to a, so it will print 5 and it will print 6. Now just see what I've done is, so I've swapped the contents of the address location pointed to by valx and val y using temp. So now what I've done is again I've printed. So here valx value referred to referred by the pointer valx. Now it will print 6. This will print 5, right? Okay. Now since valx and val y are pointers that are capable of pointing to a and b, what has happened is the content of the address location allocated to a and b has changed, because of which here now what we'll have is we'll have value of a as 6 and value of b as 5. So this is one of the important characteristics of call by reference. So as in case of call by reference, the address of the actual parameter is passed to the formal parameter, so any change brought about using the formal parameter will be definitely reflected to the actual parameter, right? So this is a very important characteristic that you need to know about call by reference and call by value. So in today's class, what we have learned about is we have learned about the importance of main function, right? We have learned about what is significance of identifier main in main function, right? Then we have learned about the way how to create a main function. We have learned about the return type of main function, the significance of return type. Then we have learned about C++ function prototype. We've learned about the importance of the prototype. We've learned about the syntax of the prototype. We have learned about the individual components of the function prototype, and then we have moved on to function definition. We've learned about the significance of function definition. We've learned about the various components of function definition. Right? We have learned about the function definition, declaration and function definition with the help of an example, right? Where we have implemented a calculator that's capable of performing basic arithmetic operations using multifunction, using multiple functions. Then we have moved on to different ways of invoking functions in C++. We have learned that there are two ways. They are call by value and call by reference. So in case of call by value, what happens is the the actual parameter is copied into the formal parameter. So any change that is brought about in the formal parameter is not reflected to the actual parameter. So we have explained it with the help of an example. And in case of call by reference, we pass the address of the actual parameter to the formal parameter. So whenever we pass the reference, it may so happen that if any change is brought about using the formal parameter, changes may be reflected to the actual parameter. And we have explained it with the help of an example. So this is what call by value and call by reference it is, right? So in the next class we will learn about functions in greater detail. So thank you very much.